Hello everyone, welcome to Form 3 Mathematics, Chapter 5, Trigonometric Ratios. And in this video, we're going to look at a summative exercise 3, which is based on the Part 4 and Part 5 video. So I would advise you to watch the Part 4 and Part 5 video before you watch this video. The exercise in this video is provided and you can download the exercise in the link provided in the description below. You should download and print and complete the exercise before you watch this video for the complete solutions. Now let's start. Question number 1, determine the value of the side BC of the following right-angled triangle given sin x equals to 2 over 3. So for this triangle here, you're given sin x equals to 2 over 3, so you know that I'm going to use this to help you to solve. And before we start, it is always easier if we try to identify all the sides here. Okay, since this is a right angle triangle, so this side here, which is the longest side opposite to the right angle, is hypotenuse. And if this is a reference angle x here, this side here will be adjacent side, and this side here, which is opposite to the angle, will be the opposite side. And since given sin x here, we need to use this formula where sin x equals to opposite side over hypotenuse. So the opposite side here is this side, which is BC, and hypotenuse is this side here, AB, which is given 10 cm. We can rewrite this as sin x equals to opposite side BC over hypotenuse, which is 10. Sin x equals to BC over 10. And sin x here, we can rewrite this as 2 over 3. So 2 over 3 equals to bx over 10. And in order to find BC, we move the 10 to this side. It becomes, so 2 over 3 times 10 equals to BC. And you get BC equals to 6.67 cm. So BC is the side that we are looking for, hence BC equals to 6.67 centimeters. Given tangent theta equals to 2 over 3, find the length of the side BC. Okay, so in this right angle triangle here, we have this side AB is 15 centimeter. We are looking for BC. So first we label all the sides. Since this is a longer side opposite to the right angle triangle, this side is called hypotenuse. And since this side is adjacent to the reference angle theta given here, so this will be adjacent side, and this side, which is opposite to this angle, will be opposite side. Okay, so tangent theta is given, so we use tangent x. So x here is the theta here, which is this angle, the reference angle, equals to opposite side over adjacent side. Opposite side is this, which is BC. Adjacent side is this, which is AB, or 15 centimeter. So tangent theta equals to BC, opposite side BC, over 15. Adjacent side here, 15. And given tangent theta equals to 2 over 3, we can rewrite this as 2 over 3 equals to BC over 15. And we move 15 here, we get 2 over 3 times 15. And we can find the value of BC, which is equals to 10 centimeter. Determine the value of x if sin theta equals to 12 over 13. Theta is given here, and x is the length of this side. So before we start, we name the sides. So this side, starting with this side, is hypotenuse. This side is adjacent to theta, which is adjacent side, and this side is opposite, hence it's opposite side. Since sin theta is given, we use the formula of sine, and sin theta equals opposite side over hypotenuse. Opposite side given is this side, and hypotenuse given is here, which is 26. So since there is no label here, so we just call this side the opposite side. And we can rewrite this as sin theta equals to opposite side over hypotenuse, which is 26. And given sin theta is 12 over 13, so we replace this with 12 over 13. We move the 26 here, you get 12 over 13 times 26. Calculate this, we get opposite side equals to 24. Is this the final answer? No, because even though we know this side is 24 centimeters, we are actually looking for the length of the adjacent side. So now, since we know the opposite side equals to 24 centimeters, the diagram now becomes this. This side is 24. And since this is a right angle triangle, we can always use Pythagoras theorem to find x. According to Pythagoras theorem, the square of hypotenuse equals to the total of the square of the other two sides here. So 26 squared the length of the hypotenuse squared equals to the square of this plus the square of this side, which is this. So we find the values, we bring this to the other side, you get this. We minus this, you get 100. To find x, we square root 100 and we get x equals to 10 centimeters. That's the final answer. Diagram shows a right angle triangle PQR. Given that sine of the angle PQR, so it's P, since Q is here, is in the middle, hence the angle is here. This is the reference angle, equals to 4/5, and PQ equals to 15. PQ equals to 15 centimeters. Determine the length of PR. Find the length of PR and then find the cosine of this angle. Now, to find PR, given this information and this information, so we know that we need to use the formula of sine. Okay, and sine x equals to opposite side over hypotenuse. So according to this reference angle here, we can label these three sides. Okay, so this is the hypotenuse, this side is adjacent to this angle, so adjacent side, and the last one of course is the opposite side. To find the opposite side is PR. Hypotenuse is this, which is 15. So now we try to substitute this inside. So opposite side we replace with PR, hypotenuse 15. So sine x, or sine of this angle, the angle that the reference angle here, equals to PR over 15. Then since we are given this, which is equals to 4/5, we just replace this with 4/5 equals to PR over 15. We move the 15 to the other side, we can't multiply. We calculate this value, you get PR equals to 12. Hence, we now know that PR here equals to 12. So now to solve B, to find cosine of the angle PQR here, we need to use the new information which we determined from question A, which is 12 centimeter. To find cosine here, we use this formula, cosine x equals to adjacent side over hypotenuse. But the adjacent side here is not given, and we don't have the information. So we cannot fill in the values into the formula. So in this case, we need to find adjacent side first before we can use the formula. So in order to find the adjacent side, since the other two sides are given and this is a right angle triangle, we use Pythagoras theorem, where the hypotenuse squared equals to the total of the square of the other two sides, which is 12 squared plus this squared, the adjacent side squared. So PQ squared equals to QR squared plus PR squared. So PQ squared equals to this QR squared plus PR squared. We fill in the values. PQ is 15, PR 12, 12 here is 12. We solve this. Okay, so we move this here, we get minus 15 squared minus 12 squared, you get 81. To find QR, we move the squared here, becomes square root, so you find the square root of 81, which is 9. Hence, we know that QR, which is this QR here, the adjacent side here, is 9 centimeters. So since we already find the values of adjacent side, which is 9, then we can fill in the formula here. Okay, so cosine angle of PQR equals to adjacent side, which is 9, hypotenuse, which is 15. And we simplify this, you get 3/5. This is the final answer. Question 5, given a right angle triangle PRS, which is this PRS, find the values of PS, value of PS, which is this, the longer side, the hypotenuse, if given sine x equals to 4/5. Okay, so this is the first information. The second information we have is QR is 4 centimeter. And the third information is x is here. The last information is this side equals this side. The length of this side is the same as the length of this side. Now, since given sine x equals to 4/5, so x is here, so we are now looking at this small triangle first. This triangle SRQ. Okay, so this red triangle here. So we ignore the other sides first. We are looking at this red triangle now. So before we look at the formula, we try to name the sides. Since this is a right angle triangle, this side here, which is opposite the right angle triangle, which is opposite the right angle, will be hypotenuse. And this side is opposite to x, so opposite side. This side here adjacent, the adjacent side. Now we look at the formula again. So since sine x is given here, so we try to use this formula first. Sine x equals to opposite side over hypotenuse. So opposite side here is this, which is 4. Hypotenuse is this side, which is QS. QS. So we can rewrite this as sine x equals to 4 over QS. 4 over QS. And since sine x is given as 4 over 5, so 4 over 5 equals to 4 over QS. Move the QS here, becomes 4 over 5 times QS equals to 4. And then we move 4 over 5 here, becomes divide by 4 over 5. In order to calculate this, we need to change the division to multiplication. So it becomes multiply 5 over 4. Calculate this, you get QS equals to 5. Hence, now we know that QS here equals to 5. QS here equals to 5. Since this side and this side have the same length, we know that this is also 5. So now, what is the next step? Since we are looking for PS, if we can find SR, this side here, then using the Pythagoras theorem, using this side and this side, we can find hypotenuse. So we try to find the value of this side. To find the value of this side, for this red triangle here, is another right angle triangle. So we can use the Pythagoras theorem together with this 5 and 4 to find this side, where the square of the hypotenuse, QS squared, equals to the square of this plus the square of this. Okay, so QS squared equals to QR squared plus RS squared. So QS squared is 5, QR here is 4, RS is the side we are looking for. We move 4 here, we calculate this, you get 9. RS equals to square root of 9, and you have RS equals to 3. Hence, RS here equals to 3 centimeters. So now since we have RS 3 centimeter and we have PQR here, 5 plus 4, we can now look at the big triangle here, the blue triangle here. So PS squared here, the square of the hypotenuse, equals to the square of this side, which is 5 plus 4, which is 9, squared plus 3 squared. So PS squared equals to PR squared, which is 9 squared, plus RS squared, which is 3 squared. So PS squared equals to 9 squared plus 3 squared. Calculate this, you get 90. So PS squared equals to 90. So to find PS, you find the square root of 90. And you have 9.49 centimeters. And this is the final answer. Question 6. Determine the following values correct to 4 decimal places. So we just key in this value in our calculator. So this is my calculator as always. And to key in cosine, we just press this button here, cos for cosine. You have this, and you just key in 26.1 since the whole values here is in the unit of degree. So you just key in 26.1. Press equal, and you get this answer, which is 0.8980. 4 decimal places, we just take 1, 2, 3, 4, 4 decimal places after the decimal point. So since this is 2 here, you don't have to add 1. So the answer is 0.8980. Option B. Tangent of 46 degree, 11 minutes. So again, you start off with pressing this button for tangent. And then you press 46. Since the angle here is in the units of degree and minutes, so the way you input the values will be different. So now after you press 46, you need to key in degree, the unit of degree, which is this button here. You press this once, you have this. And then for 11, just press 11. And the minutes here, you press this button again, the same button, you have this. This means degree, this means minutes. And press equal key, you get the answer, which is 1.0421. Since 8 is here, this you need to plus 1. So you get 1.0422. So be careful with how you input the values when the units given includes degrees and minutes. Question 7. Use a scientific calculator to find the value of x. So now you are given the sine of an angle x here is equals to this. To find the angles here, you need to use sine inverse. Okay, so x equals to sine inverse of this value. You just need to key in this in your calculator. So how to key in this? First, you press the shift button once, and then you press sine once, so that you have sine inverse. Then you key in this 0.9782. Press the equal key, you get 78.01. The answer is 78.01 degrees. Since this is 4, you don't have to add a 1 here. Look at the next one. We have cosine x equals to 0.9659. To find x, we use cosine inverse. Use your calculator, key in this. First press shift, then press cos for cosine. And you have this, key in this, and press the equal button. You get this, which is 15.01 degrees. The answer is always given in the units of degree. That applies here. To find x, you have to use tangent inverse of this value. Key in this, press shift, press the tangent, you get this. Key in this, and you have 747 degrees. Question 8. Problem solving types of question. Given a right angled triangle formed on a diagram of a tree, so we have a tree here. Yes, this is a tree, a very bad drawing of a tree. Determine the height of the tree. So the height is from here to here, which is the length of this side of the triangle. So since we are given this angle and we are given the length of the sides, we need to use trigonometric ratios, which is either sine or tangent. But before that, we try to name the sides. Since this is a right angle triangle, and this side is opposite to the right angle, this is hypotenuse. This is a reference angle, so this side will be opposite to the angle of this side. Hence, this side is the adjacent side. We refer to the trigonometric ratios. We have 3 types. Which one should we use? So first, we need to see what informations we have. We have informations for the adjacent side. Hence, we need to use adjacent side. And we want to determine the height of the tree. Height of the tree is this, which is the opposite side. So we need to choose the ratios here, which involves adjacent side, where the information is given, and the opposite side, which is the length that we are looking for. We just ignore hypotenuse because we are not looking for this and we have no information of this. Okay, so we need adjacent side, opposite side. So which one here involves both of this side, opposite side and adjacent side? Tangent. Opposite side, adjacent side. So we just take tangent x. So tangent x, x is the reference angle, which is 56. Opposite side is the length or the height of the tree. Adjacent side is 9 meters. So we fill in the values. Tangent 56 equals to height of tree over 9. We move the 9 here. You have tangent 56 times 9. And key in this in the calculator. You can find that the height of the tree is 13.34 meters. The last question. Diagram shows a right prism with a uniform cross-section of a right-angled triangle ABC. This is a cross-section which shows a right-angled triangle. And this side here we have 3 centimeter, this side is 4, this side is 8. Calculate the length of AE and the angles of EAD. So we look at question A first. Calculate the length of AE. AE is shown by this red line here. To find AE, you can actually use EB and BA, which forms a triangle. And since this is a prism, this means that EBA, actually EBA is a right angle triangle. Even though it's not very clear here, but this angle and but this side and this side here, EB and BA, actually forms a right angle here, right angle here. So EBA is actually EBA as shown here with a right angle here. So BA, we know that BA is 4, and we know that EB, which is here, BE here, is the same, has the same length as here, AF, which is 8. So we know that EB is 8 and BA here is 4, and we can use Pythagoras theorem to find EA since this is a right angle triangle. Okay, so we rewrite this as the AE squared, the hypotenuse squared, equals to AB squared plus BE squared. AB is 4, BE is 8. We find the values of this, get 80. To find AE, which is equals to square root of 80, and it is 8.94 centimeters. So now we know that AE is 8.94 centimeters. Now we go to the next question. Now we are looking for EAD, the angles of EAD. So it is clearer if we try to draw EAD using lines here. And you can see that this angle, which is formed from the two green lines. We try to look at the areas formed from EAD, which is colored as green here, EAD here. It is actually another right angle triangle because DE and EA, which is here DE and EA, forms a right angle. So here forms a right angle and DA is here. Okay, so this triangle is actually the triangle colored green. So the angle EAD, so EAD, A is in the middle here, so the angle is here at the vertices A here. So we try to find the length of the sides here. So the ED here has the same length as BC, which is 3. So ED here is 3. EA, which is this EA here, okay, EA, which is this EA here, we already found the values from question A, which is 8.94. Hence, we can use these two information to find the angles of EAD. Since it involves the angles, so we need to use the trigonometric ratios of sine, cosine, and tangent. And to choose which one to use, we need to first find the name of the sides. Okay, so the name of this side here is hypotenuse. This side is opposite to the angles as opposite side, and this side is adjacent to this angle. So for these two sides, we have the information. So we just take the opposite side and the adjacent side. So which one of the three here involves opposite side and adjacent side? The answer is tangent. Okay, we have opposite side, adjacent side. That's why we choose tangent. So now we just fill in the information here. Tangent x, x is the angle EAD. Opposite side is this 3 centimeter. Adjacent side is 8.94. So we have tangent of angle EAD equals to 3 over 8.94. We find these values here. You get tangent EAD equals to 0.3356. And to find this value, we need to use tangent inverse of 0.3356. You key in this in your calculator, you get angles of EAD equals to 18.55 degree, which is the final answer. So this exercise concludes the whole lesson of chapter 5 trigonometric ratios. I'll see you in the next chapter. Thank you everyone.